So good evening to all. Welcome to week 4 discussion for the electrical machines 2 NPTEL course. So for the last week we have started the winding in a machine. So we discussed key notations and key factors that are very important to understand the winding in a machine. So we looked into pitch factor, distribution factor, and how they are going to affect the voltage output of the machine that we have discussed. And then we derived the expressions for the pitch factor and distribution factor. So as an extension to it, this week we will see the how a three-phase winding will look like, and we will get into the uh, deeper winding analysis and winding mechanism in a three-phase machine. And let's discuss. And this will be an interesting session because uh, the winding scheme inside a machine itself is a very interesting thing to understand and to even visualize it. So how they are being placed, how the poles are being formed, how the resultant voltage we are getting out of each phase. That's very interesting to understand. So we will try to depict it as much as possible today so that it will be uh, easy to understand, easy to visualize the three-phase winding in a machine. So let's see, we'll look into how a three-phase winding will look like. And I'll take some example parameters of a machine like number of slots or number of poles. And with that, we will start the discussion. So I'm just writing down the example parameters I'm taking for a machine. So today we'll be looking at a three-phase winding in a machine. So okay. So for example, we are taking slots and pole combination. So let's say we have 12 slots and two pole machine, north pole and south pole. So I'm assuming my coil is a full pitched coil. I'm not making it that much complex right at the starting. So let's not go into short pitch or any other pitch. Let's take into full pitch. So let's not complicate it. We will start with a simple slot pole combination and full pitch winding, and we will see how a three-phase winding would look like. Okay. Now I have taken 12 slots and two poles in a machine, and I have taken a full pitch coil. So for a full pitch coil, what would be the coil span we discussed last week? If you remember, can you tell me what's the coil span for a full pitch coil?
180 degree.
Yeah, right, Dinesh. So for a full pitch coil, for the entire 180 degree, we will spread our coil. So if it's short pitched by some angle, let's say 30 or 20 degree, we will not place the coil in such a way that it's spread across the 180. So for a full pitch coil now, the coil span should be 180 degree. Now we will have to calculate the slot angle. Now we have 12 slots and we need to calculate the slot pitch. So what is the angle between each slot? So there are two methods to calculate the beta. We have discussed the two methods last week. I'll just put it down here. So one method is to calculate beta slots per pole, is equals to 12 by 2 is equals to 6. So then beta is equals to, so the entire 180 degree electrical, we are dividing it into slots per pole. For each pole, we have these many, for each pole, we have 6 slots now, slots per pole. Now, we are dividing it into for 180 by 6, 30. So another method is to go in with the mechanical. Mechanically, there is a 360-degree machine. So another So I have 12 slots. So 360 by 12. You can calculate how much is 360 by 12. Yes, 360, 30. This is beta mechanical. Now beta electrical will be beta mechanical into pole pair. Here we have two pole machine. So 30 degrees into 2 by 2, that is 30 degrees. So even this way we got beta is equals to 30 degrees only. So that's how we will calculate the slot pitch. So now we will see the distribution of the windings in these 12 slots and how we can interestingly place the three-phase winding in all these 12 slots. So for that purpose, I am just drawing the slots here. So 1, 2, 3. I have 12 slots. 12. So this is my machine. Actually, it looks like a circular thing. I have just made it into a planar just to have a easy visualization. So this is how 12 slots in a machine would look like. In actually it will come at the round. So after 12 you will again get the first slot, and before one here you will get the 12. So this is again one. So that's how the machine would look like. Now this is a slots, and in these slots we will place our windings, and it could be a double layer winding or a single layer winding, anything that could be. So let's just place one coil in slot number 1. I'll take another color. So let's say I placed one coil side. I mean this will go like this. Now it will come back and it will come back into another slot. So I have placed one coil in the slot 1. So where will be the return of this coil 1 be placed in? Any idea? In which slot I should place the return of this coil? Any idea? Which slot?
Seventh.
Yeah, that's right. So how did you get the seventh slot? How did you arrive at that number? Seventh is right.
180 degree, na?
Right, 180. That's right. So how 180 transformed into a seven number? That's what I'm asking.
One slot is 30 degree.
Yeah. So one slot is 30 degree. So there will be a slot pitch what we have calculated, that is beta, that is 30 degree. Now each slot is 30. Since it's a full pitch coil, I need to utilize the 180 degree. So each slot is 30. So 180 will be 6 slots. So if I'm placing one coil side in the one in first slot, the next one should be 1 plus 6, that is 7. So 6 comes from the slot pitch. Hello, am I audible? I think there is a network issue. Yeah. So yeah, so the return side of the first coil will be placed in the seventh slot because our coil is a full pitched coil. So I placed it in the seventh coil. So now this is only I'm placing a single coil in each slot. You can see in each slot number 1 there is a coil side. So this is entirely a coil. Let's say this is a coil 1. If this is the coil 1, this is the coil side, this particular side of this coil. This is coil side of first coil. Let's say this is coil side 1, this is coil side 2. These two coil sides will make it a single coil. Now each slot is having only one coil side, and for completing one complete coil we are taking two slots. So this is a kind of single layer winding. So for if it's a double layer winding, I'm just drawing it here. Let's say these are 1 and 7 slots. If it's a double layer, I'm writing here. In double layer, the name itself says that there are two layers. Now I'm dividing this each slot into two decks. I will place two coil sides in single slot. In top deck one coil side, in the bottom one coil side. Let's say, see this one I'm passing it in this. If you see this, 1 is going like this and 7 is the return side. In a double layer winding, the terminology usually they say it, the incoming coil slide we will place on top and the return coil slide we will place on the bottom deck. So here you will understand. Let me take the blue pointer. I'm just trying to place this particular one, coil number 1 we have seen in the single layer in the double layer. So I'm placing it like this, and the return I will place in the bottom. So this is, I will call this as 1 and I will call this bottom as 7 dash. So it is easy to remember. It is easy to differentiate between a incoming and a outgoing coil. Now 1, based on the slot number, the convention is named in such a way that by looking at a number of the coil, we can say whether it's an incoming coil or a returning coil. So 1 and 7 dash. So let's say there is some other coil which is returning in the coil number 1. I will place it in the bottom. This is 1 dash. And there is some other coil which is starting from the coil number 7. I will place it here. And this will be 7. Now, that's where the formula came. So for a double layer winding, if you see, now in these two slots, if you see in the single layer winding, two slots took to complete one coil. So one coil is taking two slots. Now if you see this particular double layer winding, in these two slots I accommodated two coils, right? Coil side 1 of this one, coil side 2 of this one coil is complete, and there is another coil slide in the bottom and another coil slide in the top. So I completed two coils. So that's where the formula comes for a double layer winding. Number of slots is equals to number of coils. So that's the another indication. Another indication for a double layer winding is you will see the same number is given for two coils, but the convention is different. So there might be a one coil, there is 1 and 7 dash. So you will see the 1 in some other coil also, but there it will be 1 dash. Then you should understand that, okay, inside the slot 1, there are two coil sides. So then you should understand that, so it's not a single layer winding, it's a double layer winding. Okay. So that's how if you are given with a winding diagram, by looking at it, uh, uh, if you want to say whether it's a single layer or double layer winding, this is one way to say that. So okay, so yeah, this is the how you can place a coil side in the slot if it's a single layer, how you place a coil in the slot if it's a double layer. Now let's see some key points before going into a winding diagram. So key points means key calculations that are important. These are easy only. Yeah. So the first one I'm just writing it here. So it's 12 slots, two pole machine. That's okay. And we are taking a three phase double layer winding. Now another thing we took is the full pitch coil. Full pitch means epsilon will be 0. There is no short pitch angle. The concept of short pitch is not there. So the first point. So I want you also to answer these simple questions. So you'll also get used to this terminology. So first point is total number of coils. So can someone tell me how many coils will be there in this entire winding if it's a 12 slot machine? How many coils will be there? So since it's a double layer winding, number of slots will be equal to number of coils. So just explain that. So number of coils will be 12. And second point is number of coils per phase. I have coils 12. What is my machine? It's a three-phase machine or single-phase machine? It's a three-phase machine. I wrote it here, three-phase. So coils per phase will be 4. So what do you mean by 4 coils per phase? So we have R, Y, B. Let's say it's a three-phase machine. Under each phase, I should place 4 coils. So that's what it means. We will clearly see that in the further pictures. So but now before we are already calculating with the numbers we have. So there should be 4 coils per phase. So R should have 4, Y should have 4, and B should have 4. Now the third point, slots per pole. So 12 by 2, it's a 12 slot machine and 2 pole machine. So 6. So each pole should have 6 slots that is swept across 180 degrees electrical. So that's the slot coil span. So that's the 180 degrees spread you will see for each pole. Now from here only we got the beta actually. Beta is equals to 180 by 6. So each slot would take a 30 degree. Now that is the angle between 2 slots. Now for each pole we are giving certain 30-degree angle, and there are each pole we are assigning 6 slots. So that's what it means. The number of slots per pole. So we are arranging 6 slots per each pole. Therefore, for each pole there are 6 slots available. That's what we have seen in the previous one also. So if you go this diagram, so the entire first 6 slots will be under one pole, north. So from 7th, the south pole will start. That's why we are placing the first one here, excuse me, and the return one in the 7th one, so that it will start at the very south pole. There will be complete 180 degree will be spanned by this entire coil. Now the 6 slots are available, so that is slots per pole. So this means out of these 6 slots per each pole, we will have 3 phases. Now out of 6 slots, we have to divide 2 slots to R, 2 slots to Y, and 2 slots to B. That is normally that's a common sense. Like if we have 3 phases and we have 6 slots, we will give 2 slots to each phase. Now again, if we look into this one, maybe if I'm placing the first 2 for R, next 2 for another phase, next 2 for another phase. That's how we will place the coils. We will see which 2 slots will go into which phase. We will see that next in detail. Okay. Now I know how my slots will be assigned to which pole, and which not which all slots will come under which pole, and which 2 slots will be given to which phase. That's all we understood now. Now let's start with the winding diagram. Okay. So see, winding diagram will be very simple. You just have to pay attention, and you have to pay attention for the coil span and slots per pole combinations, and it will be very easy. It's just a number game. Okay. Now see, this there are 3 phases like R and Y and B. All these windings are exactly similar. They are just displaced in space: R phase and Y phase and B phase. Right. Now I'm just writing it here. R, Y, and B. Let's say I'm starting with R phase. So let's say I'm starting with North Pole and South Pole are there, and first coil I have placed. Let's say this is coil number one. Sorry, coil number one. It's going and coming back at the seventh one, right? So it's I'm marking it as 7 dash. So the immediate next slot also I'm using it for the R phase. So I will just place it here and it will be 2. Now in which slot it should return? Can someone tell me what is the return number of the second one?
8 prime.
Yeah, simple. Like it had a coil span of 180. So 180 means 6 slots. 1 plus 6 we got 7. But since it's a returning terminology, we have marked the dash. Now if you are starting the coil side in second slot, I will go with a 180 complete full pitch, and 180 means 6 slots here. I will return my second coil in the 8 dash. So these two slots I will take it under North Pole or South Pole, anything it could be, North Pole or South Pole. If I am placing two coils in South Pole, and the rest two coils will go into the North Pole. So because I know under each phase I need to have four coils, so that's what the second point says. If you see, there should be four coils per phase. So this is R phase, and this is Y phase, and this is B phase. So there will come another two coils. I don't know what are the numbers of it, what are the slots, we will look into it later. But this is the terminology. Each phase will have four coils. Now 4, 4, 4, these are 12 coils. So that's the total number of coils, 12. That's why we will arrange it into all the three phases. Now, okay. Now let's look into the next part, which is the starting point of Y phase. Now see, the first coil is the starting of the R phase. Now can someone tell me what is the starting point of Y phase? So it's a little bit conceptually you have to think. It will be easy if you can get it. Like, can anyone tell? Can anyone guess it? So what will be the starting coil of Y phase? But I'll just give you a hint. Yeah, Dinesh,
120 degree, huh?
that's right. So R and Y are 120 degrees separated in phase. Yeah, you are close. Now, if it's 120 degree, how do you convert it into slots?
3 slots. No, 4 slots. 4
120,
slots.
four slots. That's right. Because beta, each slot is taking 30 degree, and you know that R and Y are displaced by 120 degree. So each slot will be 120 by beta, that's 30. So each slot will take a 30 degree. So Y will come after 120 degree, which will transform it into four slots. So I'll just do it in a R and Y and B. So this one we already got it, 1 7 dash and 2 8 dash, and there is a 180 degree full pitch, and from 1 to this one I'm taking it a 1 plus 4, that is 5. I'm again taking the how we got the 4. 4 we got, like each slot is beta is equals to 30 degree. Now R and Y are displaced in 120 degree in space. So now number of slots is equals to 120 by 30 is equals to 4. So if R is starting in slot number 1, so Y should start in slot number 5. So that's the 5 I have started. Now again the same, even I told you all coils are similar, it's just displaced by some angle. Now if Y is starting at the 5, this particular coil should end at again 180 degree full coil span only. 5 plus 6, 11. So if I am placing another coil, that is Y, is there any other color? purple. I'm placing the coil 1 in 5, that is top nut, that is incoming coil, and the return path would be 5 plus, what is that, 11, right? 11. 11 slot is here in the bottom, in the bottom. That's it. Now the next slot, immediate slot also I will take for Y phase only. I will place in 6. If I place in 6, it will come back in bottom deck of 12. That's it. Okay. So this also we have got it. Now next one is 6. This is 11 dash because it's a returning side. And if it is 6, it's in the 12 dash. It's the second coil in the Y phase. So let's, similar thing we will do it for the B phase. Now again, Y and B are displaced 120 degree. R and B are 120 degree. So if it's Y starting at 5, then my B should start at 5 plus 4. That is the 9. Now again, 9 coil is starting at from the B side and it is having a 180-degree coil span. It will start with plus 6. It's a 15 dash. So can I go for 15 here? That's the trick. That's the logic you have to apply. Now I got number 15 dash. So let's go back to my machine. I have placed my coil in 9. That is the B phase. I placed it and I'm looking for a 15th slot. Is my 15th slot available? I only have 12 slots. So where should I keep my return path of the coil 9?
3.
Right, exactly. So why it is 3? Because it's a concurrent, like it's a recurring machine, it's a round machine. So after 12, you will get the first slot. So if it's more than 12, we are getting a number more than 12, we have to just subtract it from the 12. So if it's a 15, it's not actually 15, it's 15 minus 12, which is 3. Because after 12, again 1 will come, it is 2 and again it's 3. So if the number logic, if it is 13 and it is 14, it is 15. So the ninth coil, it will go like this and it will come back to the third slot. So it's not 15, it's a 3 dash. And next one, immediate next slot I will take for another B phase only, 2 slots. And the next one will be plus 6, it's 16 dash. 16 dash will be 16 minus 12, that is 4 dash. Okay. Now what we have completed? We have completed the one pole combinations. So if you go back to the second point, the third point, number of slots per pole. So it should take 6 slots per pole, right? Now let's say this is all these slots are coming under south pole. Okay. Now coil slot number 1, slot number 2, slot number 5, slot number 6, slot number 9 and slot number 10. So these are coming under, let's say, under the south pole. Now we know that in each phase, two coils each are accommodated. Now 6 coils are done now. Now I have 6 more coils. They will come under the north pole. Okay. Now all these will come under north pole. And again, we will also have to find the numbering of these coils. It's also very simple. We will look into it. Now let's start with the R phase first. So take R phase. Let's say this is under south pole. Let's say this is under north pole. Now next 2 coils in the R phase. I have placed 2 in south and I am placing the next 2 coils in the R phase in the north pole. Okay. Now can anyone guess the number of this particular coil? Where should be the next coil in the R phase should start if it is having the north pole under it. Okay,
7.
that's right. How come it is 7?
It is sir 1 plus 6 now.
1 plus 6, like why it is 6? That's right. 1 plus 6.
North and south 180-degree apart.
Sorry?
North and south they are 180-degree apart.
Yes, exactly. Now, if you see, it's a two-pole machine, south and north. Now, we know that each pole is separated 120 degrees apart in space. Now, if north pole is starting at 0 degree and the south pole should start from the 180 degree, that there is a 180 degree apart. The poles are opposite. Now, 180 degrees will come to how many slots? It's 180 by 30. Beta is the 30 here. Now, if my south is starting at 1 and my north should start at plus 6 slots. 6 comes at 180. Now, beta is equals to 30, and north to south there is a 180 degree phase shift. Now, if my south is starting at 1 and my slots will be 180 by 30, that means 6 slots. So north and south there is a 6 displacement. So if it's starting at 1, it's starting at 7. Okay. Now again this is the full pitch coil. 7 plus 6, it's 13. There is no 13. It's again 13 minus 12. That is at the return side of the coil number 7. We will place it in the coil number 1, slot number 1. So that's why we will name it as a 1 dash. So the next immediate slot, that is 8th slot, in the 8th slot we will place the next coil, and the incoming side will be 8 and the return will be again plus 6. That is, here the 6 is because the coil have a full pitch wind. Full pitch means 180 degree spread, and 180 degree spread means 6 slots, and 8 plus 6, that is 14. There is no 14, so it will be a 2 dash. So if we try to place it here, so the 1 has gone here, but next one in the north pole comes at 7. So 7, it is going on top. 7, it will go here and it will return in the 1 dash. So it will be on the bottom, and the next one in the 8th one. 8th one, if you are placing like this, it will return in the 2 dash. So that's how 1 dash and 2 dash. It's simple. It's looking a bit clumsy, but if you see in here, it will be easy. So yeah, that's how we will see it. Now let's complete the other 4 coils quickly. So that should not be a big issue now. So it's a what is the number for this? Sorry, what is the number for this? You can calculate this number in 2 ways. That is either using north to south phase shift or R to Y phase shift. So if you use R to Y phase shift, you know R and Y phase are displaced by 4 slots. Now 7 plus 4, it will be 11. It will be starting from 11. Now if you take within Y phase, it's coming under south pole, it is coming under north pole. So there will be a 5 plus 6, that is the 180 degree spread. So again you will also get the 11 only. So anyway you can make it. That's why I'm saying it's very easy. You just have to be comfortable with the numbers. Now if it's 11, you just have to go with a plus 6, that is 17. So it's a 5 dash, and it's the immediate 12. You will go with plus 6. It will be 6 dash, right? And again this one, anyone can tell me this number? So it is 9, 9 plus 6, or 11 plus 4, 15. So it's a 3, and again plus 6, 9 dash, and the immediate next slot 4 plus 6, that's 10 dash. So now if you see, all the 12 slots in my machine are filled. Even each slot is filled with a double layer kind of. So if you see 1 here, there will be 1 dash here, 2 here, 2 dash here. So 3 here, 3 dash here, 4, 4 dash, 5, 5 dash. Every number you will see two conventions, 5, 5 dash and all. So now, this actually represents a double layer winding, because in each slot you have incoming coil side and the returning coil side. So that's it. This is how you place a three-phase winding. But now important thing is how you will join them. So uh, placing winding is not our main aim. After placing them, you need to take the terminals outside, R terminal, Y terminal, B terminal. So they should be available for giving the supply or load, right? So that's how the you have to give the supply and you should get the maximum voltage as an output. So how you will connect each phase? So see, R phase means within R phase they should be connected, right? They should be connected. Suppose like you remember the phase diagram, like R, that is R, and if it's R by B like this. So R1, R2, Y1, Y2, B1, B2. So there should be two terminals, R1 and R2. There should be two terminals coming out. So R1, there is one coil, and this is R2. So you need to connect in such a way all should be in series connected, and they should be additive to get the maximum voltage. That's how you should join these coils. So we will see that how you're going to add it. But before adding it, you should mark the terminals of each coil. Terminals means what is the positive and negative. So I will just take the R here. All the four coils I have in R, I will see how I can add it. So these two are at the south, I assumed. So definitely these two will be at the north. So suppose under south pole, the starting polarity I take it as a positive. I'm just taking it as positive. If it is positive, all the two coils starting under the south pole should be positive. This is 1, this is 7 dash, and this is 2, this is 8 dash. If these two are positive, then these starting coils in the north must be opposite. They must be of negative polarity. So this will be negative and this will be negative. And this is 7, 1 dash, and this is 8 and 2 dash. So see, all the four coils of R phase are completed in this three phase winding. Now the question is how to connect them. First thing is, let's see each pole separately. Like under south pole we have two. So one 7 dash and two 8 dash. Right. So we will connect them first them together. If it is plus, this is minus. This is plus, this is minus. So I want to connect them in series, and the voltage should be additive. So I will connect another color. So I will connect this particular 7 to the 2. So minus and plus, they will be in series. I am connected in series. So I will call this group a single group of coil. This is distributed winding, right? This is not a concentrated. Concentrated means in all the coils will go into single slot only. But we have distributed these coils across 12 slots. So this is a distributed kind of coil. So this is one such coil group. 1728 I have connected. This is a single coil group. I will call this as a coil group 1. One coil group in a entire distributed coil. So this is 1 7 dash and 2 8 dash. This is one coil group. Now let's say this is one terminal I have. Now I want to connect the two coils in the north pole also. So this is plus and this is plus, minus plus minus plus. Now again I will join this 1 dash to the 8 in series. Again these are current in series, so my voltage will be additive. Now ultimately I should have two terminals, R1 and R2. So all these four coils will also be connected among them. These two coil groups. This is coil group 2. This is 7 1 dash and 8 2 dash. So if I want to join these two, how will you join? Can someone tell me? So should I join this 8 dash to 7 or 8 dash to 2? Main thing is my voltage should be additive. So I should get the maximum possible voltage. So I should connect this 8 to this particular 2. Minus is being added to positive terminal so that it will come in series and also additive. And now this 7 will be taken as an output. Like this is the terminal which will be coming outside, and that's how. So all the voltages become additive, and I am naming this terminal as R2. Now R1 and R2 are the terminals which will be available for connection, so we can give a supply to it. So we have two groups of coils. Immediately we connected some coils in series, same coils in series under the same pole, and under each pole we will make sure that connection also becomes additive. So that's how you should be careful while connecting this coils across the poles. So make sure that the minus is going to plus terminal only. Then only you will get a maximum, or else the entire voltage will get cancelled. That also we will see in the phasors clearly. But I am telling you, if you want to get a additive voltage, connect in series, but to the opposite terminal, so that the entire voltage will be additive. So let's see this particular connection in the machine diagram itself. So I just took a machine here. This is, till now we have seen it in a planar, but if you see it in a machine perspective, you can see how the poles are being forming, how the R phase is forming, how the B phase is forming. So I'm just marking the slots here: 2, 3, 4, 5. It's a 12 slot machine we took, right? 12 slots and 2 pole machine. So the first coil we have connected is 1 7 dash, and that is 2 8 dash. So just drawing it here. 1 7 dash and 2 8 dash. These are coming under south pole we assumed, and the next one is 7 1 dash and is 8 2 dash. Then they definitely will come under north pole. So we will see that connection here itself now. See now the start of each coil we know the numbers, and R phase coils, all the 4 coils we know. So let's place it here. So in the first 1 and 7, so 1 here, I'm drawing it as bigger circle, that is the incoming one, and 7 dash at the here, a smaller one. So 1 is going and 7 is coming back, and the next one is 2 and 8 dash, second one at the top deck double layer, and 8th slot is this one coming back. Now the next one is 7 and 1 dash, 7 here, the big one, 7, and return path is 1 dash here, and in 8 2 dash, 8 and 2 dash. So we completed all the R phase windings. So R phase is completed now. Now the polarity is what is it is important. Now see, if I have connected the coils also, I have connected 8 2, and I have connected 1 dash and 8. So this is what we will see it here clearly. So this is what, so if I am sending the current here, let's say I'm current, the entire coil comes down to this. This is R1, this is R2. My current entering R2 and leaving, entering R1 and leaving R2. So this is how the current will travel like this. This one, and it will leave like this, right? Okay. Now this is the current that is flowing through the R phase. We will give the notation in electrical engineering. If it is entering, we will assume it as cross, and if it's leaving, and we will assume it as a dot. Now if it is entering 1, let's say it is assuming cross, it is leaving 7 dash dot, and again it is entering 2 cross, leaving 8 dash dot. Now this is what we will represent in the machine diagram also. So it is 1, it is cross, 7 dot, and again entering dot. It is leaving. So it is leaving and entering into 2 dash. It is cross, leaving 8 and entering 1 dash, leaving output, that is dot. Now if you see inside the slot 1 and 2, 1, 2, 1 dash, 2 dash, all are having crosses, right? Cross, 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 cross. Now, what are the notations for 7 and 8? 7, 7 dash, 8, 8 dash, all are having dots, dots, dots. So these are all forming one group, cross group. These are all forming cross group, and the bottom are forming dot group. Now, how will be the resultant field will be? So right hand thumb rule, it is going inside and coming from the dot, and it will be this side, right? Going inside, and this will be like this. This will be the resultant R phase field will be. So I hope you can able to understand it. So to see machine how the poles are produced, so that's how you will connect all the windings like this, and you will just pass a DC current and see the current distribution. So there we will see how the poles are forming. Here we see two poles. So 1 and 2 we have grouped together, that is cross 1, and 7 and 8 we have grouped together, and the lines of force you see, this is going from south pole to north pole, right? So that's how the poles are being formed. If entire this side is south pole, then this side will be north pole. So that's how the poles will be formed in a machine. So see, nothing complex here. It's just you have to make sure where the coils are being placed. The numbering should be very right. Numbers should not be confused. Once you got all the numbers and how you place all the this one, and it will be simple. Nothing much to worry about. So see, this is the distributed. That's why you are distributing it in 1, 2, and 7, 8. If it's a concentrated winding, there is no much. This is slot number 1. Let's say this is slot number 7. So and all the slots will go into one only. So here there are cross are being distributed across 1 and 2, but here all this is 1 and 7. All crosses will go into single slot. This is concentrated winding, and all the dots will go here, dots and dots. Now even here the field will be like this, but it's a concentrated winding. So that's how this one. If it is distributed, you will get two poles, but you can group these two slots together. Again you will get the same cross distribution. Sorry, that's how we can group and still get two poles. Okay, let's see the similar distribution for the y and b quickly, and I'll just erase it. The addition, I'm saying how the uh, connections will be done in y and b. So that's when we can complete the full machine here. It's just you have to see where are the plus and minus, and just connect the uh, windings in that way. I'm just drawing the top coils numbers only. Just I don't want it to be clumsy for you. That's why 5 and 11 dash, 6, 12 dash, 11, 5 dash, 12, 6 dash. So again, these two comes under south pole 5 and 6. So we assumed already this is south pole to be positive, and this will be negative. If these two are south, the starting coils of north pole will be negative, and this will be positive. Same kind of connection. Before that, let me just draw the B also. These are 9, 3 dash, 10, 4 dash, 3, 9 dash, 4, and 10 dash. So how we will again plus minus plus minus minus plus minus plus. So let's quickly join these coils, and while joining make sure you are having the series connected and additive nature. Now this is one terminal, and the 11 dash I will connect to 6 minus to plus, and within north pole I will connect first minus to plus, plus to minus. I formed two more coil groups, and now I will join this south pole coil group to north pole coil group by checking where my minus will go to plus, and then again this will form the y1 and y2. So similarly, this one, if it's b1, I will just join the minus and plus of south pole first. Let's join plus and minus of north pole second, and just then connect these north and south together, minus to plus here, and then this plus and minus 9 and 3 will become the b1 and b2. That's it. So that's how you will also place the coils and connect each other. Now let's look at this particular diagram and how we can place it. I'm just taking different colors for different groups. So let's do it for the Y phase. Y phase we have 5 and 11, right? 5, 11, 5 and 6, and 11 and 12. 5 plus, what will be the next one? 11 dash, 6 plus 5, 12 dash, 11, 5 dash, 12, 6 dash. So positive, negative, positive. 12 I'm adding to 6 dash, and then this negative and positive. Okay, so 5 and 12. Okay, now let's see. 5 and 6 are here. Okay, at the bottom you can see 5 and 6 slots. I am placing one slot here, bigger one, and the return I am placing it in the 11 dash. So I'm just drawing the 11 dash as a smaller one because it's since it's a double layer winding, just to differentiate it. Okay. Now the next slot immediate I will start in the sixth slot. Sixth slot. The return will be in the 12 dash. That's okay. Now the next coil group under this north pole will start in the 11th one only. So 11th one top, it will come back in the fifth one. Next one immediate 12th one, it will come back in the sixth one, 6 dash. So now can someone tell me the dot and cross of it? So here also same current I'm passing it. I'm coming at 6 and it is entering, it's leaving. Okay, if you see the 5 and 6 slots are having the crosses here entering. So all 5 will have cross, and all 11 and 12 slot coil slides will have the dot. Now these will form a coil group and these will form a coil group, and if you see right hand thumb rule, it's entering here, coming out, and you will see a like this. This is how we will see for the Y phase. This is how it is for the R phase. And now what's left is the B phase. So I am just drawing for the B phase here itself. 9 3 dash, and it is 10 4 dash, and then we have 3 9 dash, 4 10 dash. The joining also we remember, 4 dash will come to 10 dash and 9 dash will go to 4, and these two are the terminals. Now okay, the first we are placing 9 and 3 dash. 9 here, let me take another color. 9 first one, and 3 dash small one, and the next one is 10 and 4 dash, 10 and 4 dash, and the next one is 3 and 9 dash, 3 9 dash, and 4 and 10 dash, 4 and 10 dash. So again the dot and cross I am marking. 9 and 10 are having going inside, that is cross. So 9 and 10 are having cross. Easy current to see the current distribution, that's it. So then the 3 and 4 will have the dots. These will form one coil group. This will form one combined coil group. and if you see the current distribution and the resultant phase of B phase, right hand thumb rule, and it will go in the downwards. This is the B phase. So here also you can see how they are 120 degrees displaced, the phasors R, Y, B, and they are, you can visualize it here clearly, I guess. So see, if you see the complete diagram also. Now all the sides, all the dots and crosses, if you are see they these three, this what is the blue one? This is R, and this is green one is B, and this one is red one is Y, RBY. That's how it is coming. So all these three, you can assume these are under the single pole, and these three, these are under another pole. Maybe if it's north, and if this can be south. So that's how they are distributed. So this is the type of winding, and you can see each there is a 60-degree phase spread winding. So if you see R inside the 180 degree, R is taking 60, B is taking 60, and Y is taking 60 within 180 degree. So that's what we call a 60-degree phase spread winding, right? All three phases are shared equally inside the 180, and within 180 each phase is taking 60, 60, 60. So this is a 60-degree phase spread winding. So if you look at the phases here, let's look at how this is how the current has been distributed and voltages has been generated, because we already made sure that if I'm connecting like one terminal to this in such a way to plus and minus, then only I will get the maximum voltage output. So we made sure. So how I can get the maximum phasor voltage output? So if you see how we will get the maximum, so we just have to pay attention to the phasors one, like phasors, how the phasors would look, and how we have added each this one to that one. So see, let's look at phasors now. Let's look at how R phase phasors would look like. I'm taking R phase first. So I know this one. I started with 1 7 dash, and 2 will go to 8 dash, and here it is 7 1 dash, and it is 8 2 dash. I joined 7 and 2, and 8 dash 2 dash, 1 dash 8, and 1 and 7 are output terminals such as R1 R1 and R2. Right. Now suppose my each coil is giving me some voltage like E1 7 dash, E2 8 dash, E7 1 dash, E8 2 dash. These are respective voltages which are equal in magnitude, but they definitely their angles would be displaced according to their slot's position. Now suppose my I'm drawing the first one, E1 7 dash is a phasor somewhere in space. Now what will be the angle between E1 7 dash then the immediate E2 8 dash? Can someone tell me? It's slot number 1, slot number 2. This is 1 7, and this is the 2 8. So definitely they are 30-degree displaced in the machine. So each slot is sharing a 30-degree. So if you see this one and this one, there is a 30-degree angle. So 1 7 dash and 2 8 dash, these two coils only we are looking at. They are displaced by 30-degree. Now I am drawing it. If my E1 7 dash phasor looks like this voltage phasor, and at a degree 30-degree lagging, that is beta, my next voltage phasor E2 8 dash will look like. But now I am just placing it here to get the resultant voltage, how my resultant voltage would look like. So that is my E28. This is nothing but the beta degree lagging, because if you are looking at circular anti-clockwise direction, so first I am getting the 1 7 slot winding, and next we will get the second slot if it goes in the anti-clockwise. So that's how. Now where will be the E7 1 dash with respect to this reference? That's easy. So it will be 180-degree displaced and out of phase with the 17 dash. So if it is E17 dash is like this, because definitely E1 is placed in North Pole, 17 dash is in South Pole, right? We assume that it, yeah. So then 7 1 dash will be North Pole. So they are 180-degree displaced and out of phase. So this will be E7 1 dash 180-degree out of phase. This is the direction of E7 1 dash, right? Okay. So now, because just whatever happened to 17 dash coil, same thing will happen to 7 1 dash after 180-degree. So that's how they are displaced. If it is one slot is here and the seventh slot is at the bottom, so there is a 180-degree displacement. That's why it's happened. Okay. Now similarly, this E82 dash, it is again 30-degree displaced with this particular. This is how it should be. This is beta, and I'm drawing it here. E82 dash. This will be the beta. Okay. This is how we have connected. Now see, uh, this is not connected. These are the phasors. Now, if somebody by mistake add all these phasors, what will you get? If I don't, I have not pay attention to the like positive and negative here. I just connected. I just connected like this. Positive, all the four coils here, right? I just connected in series. I just connected this. I just connected this. I just connected this. So this phase and this phase. So this is also series connection. This is not a wrong connection. But I just didn't pay attention to the voltage terminals. Where is positive? Where is negative? I didn't pay any attention. If you do it like this, the disadvantage is they might get cancelled because they are just equal and opposite. Now E1 dash and E7 dash, they will get cancelled because 180-degree. If you add these two, the resultant is 0. If you add these two, the resultant is 0. So the resultant voltage will be 0 here. But that's not what you want from the machine. You want the maximum possible voltage. So that's why you connected the negative to positive so that it will become additive, and then there is a negative positive here. You connected in such a way. That's how you have grouped the coil. So what will be the net voltage if you add on the four voltages? You should make sure that I'm getting a maximum voltage output. That's what we need to take care. Every voltage should be additive in nature. So now if you look at the phase are now after grouping whatever we had grouped. So what we did, so E17 dash, then came the E28 dash. This is positive and negative. We connected 17 dash to 28 dash. Right, that's correct. Then this is plus and minus, and we have minus plus here. Then this is 7 1 dash, and it is 8 2 dash. Again, these have minus and plus. We connected this one to this. Now, what we connected, next step, what we connected is we connected 2 8 dash coil to this 8 2 dash, but in reverse way. We have not connected to 8 2 dash, but we connected to the second side. So, we have taken the negative polarity of this one. So, I'm just writing it here. E17 dash, that's the first connection I made. I connected this to E28 dash, right? This is the E28 dash. Now then I connected to 2 dash end of 82 dash. That means I have taken negative of 82 dash. Okay. Now I have connected this to negative end of 71 dash. It is connected to 1 dash. That means the reverse polarity. I have taken the negative and then connected. So this is my connection. So now let's draw the phasor now. So I'm just drawing it first. E17 dash. This is E17 dash phasor. That's right. And then I connect it to 28. So 28 we know this is just displaced by beta, right? It is E28 dash. Now next I have connected to 82 dash, but in the reverse mode. Previously, the 82 dash is in this way, right? This is 82 dash. But we have taken the negative of it and then we have added it. So again, this is in 30-degree only. This is E 82 dash, but in the negative. That's how this is. Okay, I know how I represented the direction in this way, so it's negative. And then from here, the last one, it's the 7 1 dash phaser. Previously, it's here E7 1 dash. Now I'm taking the negative of it, so it will come like this to the top. E7 1 dash negative. Now the resultant is from here to here. I will draw the resultant in another color. So the resultant is from here to here. So if you see, everything is going on adding, plus this plus this plus this plus and this plus. The resultant will be this one. Now this is E. What is this? E1 dash, right? E7 E17 or what? This is E17 dash. We started E17. Yeah, this is the 7. So if you see, let's say, what is the terminal number we have given? 1 is R1 and this 7 you are getting the R2. So this is R1 and this 7 you will get the R2. So this is how you got the R1 R2 phasor. Now if you do the similar kind of phasor for Y and B, you will get similar kind, like maybe here if it's an RYB phase sequence. So this is Y1, Y2, B1, and you can see the displacement of phasors. So this is how you get. This is the R1 R2 resultant. This is Y1 Y2 resultant. This is B1 B2 resultant. So this is how you get the phasor distribution in space. And each phase you try to extract maximum possible voltage as possible. So this is in-depth discussion on the winding. I mean, you don't have to worry about the even much more complex things in the winding, but this is the basic discussion which is needed for you to understand and visualize how a three-phase winding would look like. I started with very simple slot pole combination, right? It's a 12 slots 2 pole combination because that is easy to explain and easy to show it in a machine. If we go for more slots and poles combination, it is just very difficult and confusing to even visualize it. So visualizing a lesser slot pole combination would be easy. However, the same concepts and same discussion would apply for any slot pole combination. So this is the same thing, because now we are going to look at a problem, numerical, now which we are going to solve. So if you look at that problem, it is even much more bigger complex slot pole combination. So we are not going to discuss everything what we have discussed in for that combination. But since we have discussed for a 12 slot pole, 12 and 2 slot pole combination, you can easily relate it to a bigger slot pole. So that's the reason discussing it in detail here. Now let's get back, uh, proceed further and look at our question and how we can solve it. So I want every one of you to be attentive and answer the questions looking at the winding diagram. See, I'm telling you, it's a very easy number game. So even just looking at the diagram itself, you can conclude many points. What is the slot page? What is the phases? What is the slots? How many phase per slots per pole are there? What is the beta? What are the starting uh, coil numbers? What are the missing X, Y, Z, W? Everything is, you can easily solve it in 5 to 10 minutes. Okay. So yeah, everyone take your pen and paper and solve it with me. I will just keep on asking one point. So what is the thing here? So in the question it was given. If you see the question, I have not noted down here. It's a 4 pole machine. It's given. Even you can see it here. See poles. There is a coil distribution for poles, north south, anything it is. Okay, it's a 4 pole. Okay, answer, like I will ask pretty simple questions. I want every one of you to answer. So, how many phases are there here?
Three, sir.
Yes, three phase because it's given A, B, C. Because these are all first inferences from the diagram. What are the first things we can easily guess, easily see from the given winding diagram? Okay, phases is three. Can someone tell me how many slots are there? You have to look at the numbers here because in the A phase, all the numbers are being provided for you. So, looking at the numbers, can you tell me the total number of slots that's present in the machine? So, one easy
Which is double layer?
40 slots.
40, 40 you said, Vedika?
Yes, sir.
No,
40, yes.
yeah, you should always see for the maximum number. So, 40 is one side. You have seen this one. That's fine. But if you look at the return coil sides, you can see the maximum number as 48. Uh, Dinesh also asked whether it's a singular or double layer. If any number has having two values, that's it's an indication that it's a double layer. Now one is here, there might be one dash somewhere. But if you see there are 35, 25 is there, 25 here, 25 dash is there, it's definitely a double layer binding. That's one more. And to calculate the number of slots, you should always look for the maximum number both sides. If you are seeing the maximum number in this side, it's just the starting side of the A phase. So the A phase is ending with the 40th slot. Maybe somewhere around here there might be 48 as well. So you don't know that. So you look at the both sides of A phase and see what's the maximum number here. There is a returning coil slide that is being placed in the 48th slot. So number of slots will go in as a 48. Okay. Now Dinesh already put up the point of whether it's a single layer or double layer. So we are clear now. It is a double layer winding. Now number of coils will be how much? If it's a double layer winding, number of slots will be equal to number of coils will be equal to 48 since it's a double layer winding. Okay. Now we know pole, we know phases, we know slots, and we know coils. Now we will just calculate some basic terminology, that is coils per phase. I'm just calculating how many coils should I place for each phase. Okay, a coils per phase will be how many coils I got 48, and number of phases I have 48 or 3, so it will be 16. Okay, now check the same from the diagram also. So for each phase, I need to place 16 coils. Are they tallying with the diagram? You can also cross check it. See, these are 4, these are 4, these are 4, these are 4. So total there are 16 coils in this side. So yeah, it is tallying. Coils per phase are 16. Now, can someone tell me, this is important, can someone tell me, is it a full pitch or short pitch? You just have to think a bit and tell me it's a short pitch or full pitch. If you are saying me the answer, you have to tell me the reason also.
It's a short pitch, sir.
Okay, why it is a short pitch?
The 48 by 4, it is 12. Now it is 1 plus, I think, 10. It
Yeah,
is 11.
yeah, that's right. So instead of going from 48, yeah, that's also a way. Slots per pole, it's a 12 you should have. But okay, I'll just put it down here. So let's say if it's a full pitch, I am not checking the diagram, but I am assuming my winding to be a full pitch winding. For a full pitch winding, my coil span should be 180 degree. Okay, if it's a 180 degree, I'm assuming for a 180 degree coil span, I will calculate my beta. So slots per pole, how much I got? Slots is 48. Number of poles, it's number of poles, 4 pole machine. It's a 12. Now, if you see 12, 12 slots per each pole should be swept across 180. So my beta will be 180 by 12, that is 15 degree. Okay, 12 times 15 will be 180. So if it's a full pitch and should have a coil span of 180, if I am starting my coil side at 1, I should have these many slots, 12 plus 12. My end of first coil should be in the 13 dash. So then I would say my coil is a full pitch winding. So always, if it's a full pitch or short pitch, calculate the beta, and once you get the beta, multiply it with like how many slots it would take if to reach 180. So my beta is 15 now. So to get 180, I should have a 12 slots, 15 into 12. So but if you are seeing 12 here, it should be 13 dash. But in the diagram, it's, if you see, it's a 111 dash, the first one. So 111 dash. So it's definitely not a full pitch winding. So it's a short pitch. So how many degrees it is short pitch? How do you calculate it? The epsilon. So I am sure now it is a short pitch winding. Now what is my epsilon? So to calculate the epsilon, you calculate the coil span of this particular coil. So 1 and 11 dash. So it is having a 10 slots, slot pitch. So for each slot, beta I know it's 15. So for 10 slots, it will be 150 degree coil span. So if it's a full pitch, it's a 180 degree. If it is a short pitch, here it is 150 degree. So my epsilon is 180 minus 150 is a 30 degree short pitched winding. My coil is, right? Okay, that's a procedure to calculate the short pitch angle. Okay, now coils per pole. We calculated before coils per phase. We got 16 coils per phase. Now, if I calculate coils per pole, I know we have 48 coils and we have 4 pole machine, and you should have 12 coils per each pole. See, already I know it's a 4 pole machine. Let's say this is not, I'm assuming it's not south and north. I'm just saying if it is north and if it is south. Now, under each pole, how many coils are there? 1, 2, 3, 4. These are 4. These are 4. And these are 4. 4, 4, 8, 12. Right? So this is also matching. So under each pole, there should be 12. So again, these are 12. These are 12. And these are 12. That's it. Okay, you are just matching it. Coils per pole is matching or not. Now, starting off B phase, it should be 120 degree displaced, right? That's also we know that because we saw it in RYB kind of discussion before. Now A, B here, it starts at 1, it's ending at 11 because of short pitch, and A and B I have a 120 degree displacement, A phase and B phase. Now if it is starting at 1, where it should start? 1 plus 120 degree, this one is. So to calculate 120, I know each slot is beta is 15. So 120 by 15, how much it is? It is 8, right? So you have to add 8 here and you should get a 9 here. So the B phase starting should have a 9 slot. So can you check it from the diagram? It's right. So A and B are following the 120 degree phase difference, and similarly if you see the 9 plus 10 here, and it should be 19 dash, and that's okay. So already we have solved one question. See, it is Y here. So what will be the C phase starting? And this is ABC. So 9 plus 8 na, that is the 120 degree displacement. It is 17. We already solved one question. So anyway, so that's how we have derived the initial parameters, whatever we know, just by looking at the winding diagram. Now let's get into the questions? Okay, it's very simple. You have to answer it in May. Of course, I think we already solved some of questions here. So this is the coil span. We already calculated coil span. The first one, if you want to calculate coil span, take one particular coil. By looking at the numbers itself, you can calculate it. So the coil span is sweeping across 10. So each slot is 15 degree. So the coil span will be 15 into 10. It is 150 degree. So the coil span is 150. It's easy only. Okay, next one. Okay. See here, they're asking for a pitch factor for a third harmonic. We already discussed the formula for pitch factor last week, and we also understood the significance of short pitch. So in this winding diagram, we saw our winding is a 30-degree short pitched winding, and the reason going for short pitched is to eliminate certain harmonics. So here also we have seen they're asking if I want to eliminate a third harmonic, what should be my pitch factor? So what is the formula for pitch factor? You remember the last week discussion? It's cos epsilon by 2. Now if it's for a three third harmonic eliminating pitch factor, it will be cos 3 epsilon by 2. Okay. So okay, we already calculated the epsilon. Epsilon is nothing but the 180 degree minus my coil span. Here the coil span is 150. So its epsilon is 30 cos 3 into 30 by 2. So it's a cos 45. It's 1 by root 2, right? 0.707. That's the pitch factor for it. So if you can get the 0.7 factor of pitch factor from your winding, then I'm sure that I'm eliminating all the third harmonics from the winding voltage. So that's the significance of pitch factor. Okay, phase spread. This is we already discussed how the phase spread is in our machine discussion. Now we will see the phase spread here. So phase spread means how much angle each phase is spreading in 180 degree space, right? So to calculate the phase spread, you just calculate the slots per pole per phase. That's what you want to calculate. Slots per pole per phase if you want to calculate it. So I know there is a 48 slots of in my machine there are, and how much pole, which is a 4-pole machine, and you have to divide it by phase, 3-phase machine. So it's a 4. So you got slots per pole per phase. This is the M. We call it as a 4. So with this M, you need to know how much. See, now you know 4 slots for each pole under each phase. uh, these are the number of slots. Now you want to calculate the spread for these 4 slots. Now you know each slot is having a 15 degree spread. Now for 4 slots it will be 15 into 4, 60. So now you are sure that under each phase, under each pole, 60 degree is swept by one phase, one slot pole combination. So slots per pole per phase you calculate, and you multiply it with the beta. So this will give you the angles swept by those many slots. So 4 slots are swept in 60 degree. So your phase spread is 60 degree. So if you see the machine which we have seen before, so here also slots, how many slots? We have total 12 slots, and per pole, slots per pole, you have a 2-pole machine, and per phase is a 3-phase machine. So it's 6 and 2. It's 2, and here the beta is 30, 30, right? So 30 into 2. So it's a 60 degree phase spread. That's what we also got. So under each 80 degree, so each is 30, and these two combinedly 60 degree. So R is taking 60, B is taking 60, Y is taking 60. So that's what you have calculated for this particular winding. So the next one is the distribution factor, but for the third harmonic. So from the last week discussion, we have derived the entire derivation for distribution factor. That is the sine, sorry, sine m beta by 2 by m sine beta by 2. So if it is for a third harmonic, 3D, sine m 3 beta by 2 m sine 3 beta by 2. So m and 3 we already calculated. M is nothing but slots per pole per phase. So it is 48 4 by 3. This is 4 and beta is 15 degree in this question. So KD will be sine 4 times 3 into 15 by 2 by 4 times sine 3 into 15 by 2. So you can calculate it. So it's 15 3 is a 45, 45 90, sine 90, 1, 4, sine 45 by 2. So it's sine 22.5, it's around 1.53. So 1 by 4 into 1.53, it should come around 0.653. So you can calculate it. So this is a simple application, like substitution of a formula, which we derived the last week. You can refer to the last week discussion to the derivation, how we got this formula. Okay, now the last point is we have to complete the remaining entries in the winding table, and we have to find the values of x, y, and z. So yeah, remaining entries, they have given so many empty this one. So they want us to calculate x, y, z, and w, and also the remaining empty entries. Empty entries, there are a lot. We can just complete it. It's not don't much take time. So let's just first concentrate on the x, y, z, and w. So let's calculate x first. So x, you are seeing a phase and b phase. So let me take a phase and b phase. I'm taking the first coil itself, 1 and 11 dash. 1 and 11 dash, and this is 9 and 19 dash. See, now I know the A and B are displaced. Yeah, someone wants to say something. 120. So this is a 8 slots. That is 120 by 15. So that is what I got, 1 plus 8. So to get the x, I can just add this number of 120 phase spread to the A phase. So I'm taking that particular coil. This is 14 and this is 24 dash, and this is x, and this is they have not given. So this is what they were asking. So 14 plus 8, right? So x will be definitely 22. Simple. Now what will be this particular number? So it will be again, coil span is 150, so it's swept around 10 slots. So if you add 10 here, it's a 32 and it is dash. So x is equals to 22. Now, yeah, I told you it's very simple number game if you understand the logic. Now let's calculate y. Where is y? So y is here. So y we already calculated, I guess. So if it is 9 and 19 dash under B phase, and it should be again, it's 8 slots. 9 plus 8, 17. And it will be 10, 27 dash. So y is 17. Okay, now what is z? Okay, to get z, we need to get this one first, and then we can get this one, right? 25 and 35, this one and this one. So this is 25, 35 dash, and we know this one is plus 8, this one is 33, and this one is plus 8, and this one is 41. This is Z, right? This is 41. Okay, this one anyhow you can just fill 10. This is 43 dash, and what is this one? 51. So yeah, again this comes here. You know the maximum number of slots is 48 only. So if it's 51, it's coming. It's nothing but the 3 dash, right? So anyway, the required number what we need is Z is equals to 41. So can someone tell me W dash? I'm not doing it. I want you to answer it. What is W dash? So get the starting coil of W first.
7, sir.
7 dash.
Right, 7 dash. So 37, 47, you know. So 37 will give plus 8, that is 45. And 45 you need to add plus 10, which is 55. There is no 55. 55 minus 48, it's 7. So the W dash is 7 dash. So W is 7. So I think that's it. Nothing more. I'm sure you are well equipped with the winding terminology and comfortable with the winding. I'm not completing all the okay. Some message by Abhishek. You want me to explain pitch factor? So you want me to explain the derivation of pitch factor again because that might not be possible right now. So see, pitch factor is nothing but, see, let's say you are having a full pitch coil, that is you are uh, like spanning your entire coil. So this is 1 dash. Let's say 10 and 01 dash. You are splitting over 180. You are having a full pitch. So if you are going a short pitch, let's say I'm short pitching by 150, like in this case. So this should be ideal full pitch, that is 180 degree. So I'm short pitching it by 30 degree. I am returning the 1 dash coil early, not at the 180 degree. So the reason behind doing it is if the pitch, you will get some less resultant voltage, but the advantage of this is we discussed in the last week, like if you go for less resultant voltage, you will get you'll get to eliminate some like unnecessary harmonics in the windings, and then there are many more advantages like that. Of course the resultant voltage would be reduced, but the advantage is what, so I request you to refer to the last week discussion, last week session that's available in the YouTube. There we even derived the entire expression, like how we got the cos epsilon by 2. It's nothing, it's just we will calculate the voltage if it's a short pitched, and we will calculate the voltage if it's a full pitched. Then we will cancel out the terms. It's just a ratio. So Kp is nothing but the ratio of resultant voltage if it's a short pitched by ratio of the resultant voltage if it's a full pitched. So in that you can easily get it. The voltage is reduced by a cos epsilon by 2 factor. So the derivation is available in the last week. I request you to refer it once. It will be clear. Okay. Now the rest incomplete numbers, I'm not solving it. It's just playing it with the numbers, and you can complete it well. I know you are well equipped with the terminology. So that's it. So yeah, that's all I want to discuss for today. I
Sir, one thing.
yes, Dinesh.
Sir, like this V voltage induced in per coil,
Uh-huh.
and I want to calculate the what is the maximum phase voltage calculated.
I didn't understand your question.
So, so like there's one V voltage is in one coil.
B voltage. B.
V, or you can say X voltage is
Okay. X.
generated in one coil.
Huh.
So, what is the total voltage is generated in the coil group?
In the coil group. Okay. Yeah.
Hmm.
You want to calculate that. See, if
Yeah.
you want to calculate the voltage, you need to understand the what is the in terms of actual numbers. If you want to calculate, that's not possible. Like you want to see the current flowing it, you need to get the winding resistance and you multiply it with, you will get the voltage. But if you want to calculate the, like in terms of voltages, like E1 dash, E1 dash, in that terminology, you need to see what how you are adding these coil groups within the coil group. Now there will be a resultant phasor. See, you just have to assume if it's a plus, and all these will be plus under this pole. So then this will be negative, and this will be plus, and this will be all will be negative. So the same thing applies here. You just add minus minus minus, all the is in series, and the end minus should go to positive of next coil group. So let's say these are all positive, positive. You add it here because all will anyhow will be added in this way. So again, next come back to this one. First add coil groups within, and then add see here you will be left with where this particular coil, this is one, and you will this will be negative, and you go with adding it with the positive here. Okay, and then you will be having another negative. In that way you have to proceed if you want to calculate the voltages.
So in this case, it will be maximum will be 16 V.
You are saying maximum resultant voltages. Yeah,
Yes.
you have 16 coils per phase. Yeah, see the magnitude anyhow. If it is same, then definitely it's 16 times the individual coil voltage. That's right. Yeah.
Multiply by distribution factor.
Yes, that's there because it's a short pitched. Yeah.
For the maximum current,
Maximum current.
so I want to one coil can take 5 ampere, some X ampere current.
Okay.
So, uh, so how to connect them in such a way that I can get maximum current per phase?
Maximum current. See, if you're all coils you are connecting it in series, doesn't matter. So same current will flow through all the 16 coils in a single group. So all those are coming under A phase. A is carrying IA current. So if you are passing it IA here, IA, same current flows through, and whatever it is coming out, that is also IA. Current remains same. So you need to get maximum voltage. You are connecting it in series, multiplied by pitch factor, and multiplied by distribution factor.
So it will be 16 V into I.
Yeah, multiplied
That
by
is you
KP.
can say maximum KVA per
KD,
phase.
KD will also be there. It's a distributed winding.
Yeah, yeah. And for the three phase, I multiply by 3.
Yeah, yes, right.
In this case, sir, the I is the current.
Uh,
When I am connecting series for the maximum voltage, so it is 16 V into I
okay.
into 3 into KD.
KD, KP.
KP. Okay.
Yeah, yeah, right. That is per phase you are calculating, right?
Yeah.
Yeah. Okay. So yeah, that's all for today. So we just started with discussing the how a three-phase winding would look like, and we started with the planar structure, and we discussed all the terminology, short put pole, how the coil numbering would start in each phase, how many coils should go under each phase, and how many coils should go under each pole. So with that discussion, we completed the entire winding diagram for a 12 slot two pole machine, and we then looked at the joining. How do you connect these coils to get a maximum voltage? So then we completed the polarities discussion. So then we looked into the resultant phasors of each phase. Then we arrived at the complete winding diagram in a machine. So we looked at how the cross and dot coil groups are forming, resulting in poles, and for each poles how the these phases are being spread across these poles. So then we solved a bigger winding slot problem. It's a 48 slot three phase four pole machine, And yeah, we just with the discussed terminology, we completed the winding diagram and also calculated some winding terminologies of coil span, coil phase, pitch factor, distribution factor, everything. So yeah, if you have any doubts in this particular session, you can ask. And if you want to a detailed discussion about KP and KD, how we got the derivations, I request you to refer to the last week discussion. And yeah, basically week three and week four completely we focused on windings. So next week we will proceed into some other concept. But this will be the end of winding discussion by this week. So next week we will come up with next concepts. But if you have any doubts regarding concepts of windings, I request you to refer to the week three and week four content. So if any doubts, you can ask me. Okay. If there are no doubts, I would thank I would thank you all for patiently attending the session for 2 long hours and sitting with me and listening to me and participating and interacting well in the discussion. So yeah, thank you all for joining the session, and we will meet next week 6 to 8 on Tuesday with new concepts. Thank you all. See you next week.